Well, welcome everyone to video lesson number 4, where we're going to review some concepts in nuclear chemistry, beginning with nuclear composition. So remember, what's in the nucleus of an atom are protons and neutrons. Protons and neutrons both have a mass of 1, but protons have a charge of positive 1, whereas neutrons are electrically neutral. Electrons we're not dealing with right now, but they are outside of the nucleus. They have a charge of -1 and a mass of basically 0. So if I want to know what's in the nucleus or the composition of the nucleus, I will look at an atomic symbol like we have here, and notice this number on top. Remember, the number on top is the mass number. So if both protons and neutrons have mass, that number represents the number of protons and neutrons. The number that we don't see here is the atomic number. So radon is radon because it has a certain amount of protons, and that is the atomic number. So I need to look on the periodic table, and I look up radon, and I find that it has 86 protons. Okay, that's also again the atomic number. So I can go ahead and label that right now. Protons, I have 86, and then neutrons I can figure out because 222 is the number of protons and neutrons, and 86 is the number of protons. So that means the difference between those two is the number of neutrons. So I'll take 222 minus 86 and do some simple math here, and I should get 136 neutrons. Okay? So that's how you figure out the composition of the nucleus. Now, okay, so remember that all atoms have at least one unstable isotope, and we call those radioisotopes. They're unstable because of the ratio of protons to neutrons in the nucleus. So remember, protons are positively charged and they repel each other. However, when we have neutrons in there, that contributes to this thing called the strong nuclear force and holds the atom together. Now, depending on that ratio, it may or may not be stable inside there because of the repulsion. And typically, the bigger you are, the more neutrons you're going to need to keep stable. And at some point, you can get so large that the atom is unstable and basically it will decay. So remember the 3 types of radioactive decay we talked about: alpha, beta, and gamma. Remember, alpha and beta rewrite equations for it, and then gamma is kind of associated with, or usually associated with, both alpha and beta. So let's go through an alpha decay. We have polonium-218. So first thing is to write the atomic symbol for polonium-218. So I look up polonium, the symbol is PO. I write the mass number at the top for 218, and then I have to go to my periodic table and find out how many protons there are, or the atomic number, and that's 84. Okay? Now remember, this nucleus is unstable, and so the alpha particle is emitted or sent out of the nucleus. Okay? So I show that by my alpha particle, which is a helium nucleus with 2 protons and 2 neutrons. That is going away, so that means to get the result of this, I subtract the numbers. So 218 minus 4 would be 214, 84 minus 2 would be 82, and notice 82, I have a new element because that is determined by the number of protons, lead, or Pb, okay? So remember, when we labeled these, this would be my parent isotope, this would be my daughter isotope, and then that is the radiation that is released in that decay. Okay, another type of decay we talked about is beta decay. So here I have the beta decay of zirconium-97. So again, I write the symbol, I go to the periodic table. Zirconium is atomic number 40. Okay, it's unstable and will emit a beta particle. Now, a beta particle is a high energy electron that comes out of the nucleus when a neutron gets converted into a proton. So in other words, my atomic number will go up by 1 because I'm adding a proton. So my atomic number turns to 41. My mass number is still 97 because remember, electrons have no mass. And so I look up number 41, and it's Nb. Okay, so here's my parent, my daughter, and my radiation. Okay, and last but not least, we talked about half-lives. Remember, the key to half-life problems, to unlock the mystery of these, is to figure out how many half-lives have taken place. So let's even write that down as a question. How many half-lives? So I read the problem. It says the half-life of polonium-218 is 3 minutes. How much of a 16 milligram sample would be left after 18 minutes? Okay, so I know 18 minutes have gone by and each half-life is 3 minutes. So in other words, if I take 18 minutes, the total time, and divide it by the time of one half-life, 3 minutes, that would cancel, and that would give me a total of 6 half-lives that have taken place. Remember what a half-life is? That's the time it takes for the sample to get cut in half. So basically, if I start with 16 milligrams, cutting it in half one time would give me 8, 2 times would give me 4, 3 times would give me 2, 4 times would give me 1, 5 times would give me 0.5, and then the 6th time would be 0.25 milligrams. Okay, so each time, after each half-life, it gets cut in half. So hopefully that was helpful. Please complete the review sheet and good luck on the test.